Hello and good day everyone. In the last videos, I've shown you how to set up a binary table which we can use to quickly convert decimal values into the different formats of binary numbers like fixed point format and floating point format. In this video, I'm going to show you an example on how to use the binary table to be able to add two fixed point numbers quickly. First, we will convert those numbers and we will apply the Boolean rules to add the bits one by one. To show that example, let us head over to our Google Drive and then open our binary table. So this is our binary table template, which I've shown you earlier, which we will use in converting and later adding to binary numbers. In this example, we are going to add the numbers 146.751 with the number 546.6521 on a different sheet in our Google Sheet. Sheet 1 remains to be our repository for our binary template. Let us copy this binary template over to our uh, sheet where we will convert and uh, add the two numbers. As usual, no, we are going to adjust the columns because Google Sheet does not adjust the columns automatically according to source. So the first thing that we need to do is to convert 146.4751. We will copy this to this part. And then we will start picking and marking. So this is the first value, by the way, is 4096. Let me also check I have made a mistake. This should be 4096. Let me correct that. Let, let's go back. So with 146.751, the biggest number that we can pick is 128. And when we mark it, we're left with 18751. So 18 is the next number, and we can pick 16, being the biggest number we can pick. And we are left with 2, and we are left with 0.751. Obviously, we can take zero point 0.5 and 0.25, and can we take 0.125? No, we will take 0.0625. That we also can take that. We'll only end up to the 64th bit. We also can take that. So we will only end up to the 64th bit, because rather the 6th bit, unless otherwise we are told to go beyond our that value. Now in this case, we know that the value is 100.110. And now we are going to copy this table again to convert the second number. This time we are going to delete the marks, excluding the binary point, so it still appears in our answer. Okay, and we will copy 546 instead of 1467. This is the second addend. So let us start picking. Okay, the biggest number we can subtract from 546 is 512. So we mark it. We're left with 34, so we mark 32. We're left with 2, so we mark it. And 6125 will mark 4.5. We mark 0.125. That no, we couldn't do that. We'll try 0.06. Yes. 1, 2, 3, 4, 5, 6. So we have 6 binary places. 1, 2, 3, 4, 5, 6. Okay. We also have the 64 place value. We are going to copy rather to mark mark tables with zeros. Okay. So now can we put the translations together? You also copy the place values of the first so that we can convert. No, we'll just copy the results together, put them close to each other. Is 546. We are going to check the values later by using the binary table itself. Now we will start adding bit by bit. We are going to apply the rules. 0 plus 0, 0 plus 0 equals 0 carry 0, 0 plus 1 equals 1 carry 0, 1 plus 0 is 1 carry 0, 1 plus 1 is 0 carry 1, and 1 plus 1 is 1 carry 1. We are going to apply this bit by bit, starting with the least significant bit. So we start at the rightmost. So we add this. 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is already also another 1, 0 plus 0 is 0, 1 plus 0 is 1, and 1 plus 1 is 0. We have to be careful here. 1 plus 1 is 0, carry 1. So we have 1 plus 1 plus 0 is 1. We have another 1 plus 1, which is 0. We carry 1. 1 plus 0 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. And 0 plus 0 is 0. 1 plus 0 is 1. We're left to copy because we don't have anything left. So this is our result. We can copy that. We can concat. We can concatenate this to be able to show our result. We have something wrong here. We have this is one. This is supposed to be one. So our answer is this, and we can check this answer. How do we do that? We'll copy our binary table again. Any of the two will do. And we will check if the answer equals the correct one. Copy it here. So if you'll have a formula, the sum should be equals plus 693.3665. Okay. So we'll delete this. Instead, we also delete this. We are going to plug in our answer and find out if it equals to the given value of 693.3635. So we'll mark it here. I will just copy this. Okay, this is our answer. Then we will copy this. Okay, with the 64. We miss one, we're missing one, so we'll just mark it. Anyway, it's one, so we'll just mark it this with one. Okay, so the answer is 693.6096. It's because there's a slight discrepancy because we are using only 6 binary places. Because remember, when we converted, we had a residue of 0.003 in the second number, and we have a residue of 0.001 in the first number. Okay, so that doesn't make it wrong. This is still correct, however, it's not precise because we are only limited up to 6 binary places. Let's try something where we will use the 10th binary place. Do it in here now. So let's say we add 246.751. This time we add 146.6125. That's the same thing. So this time we are going to add using 10th binary place. Let us head over to our blank table. and then copy this, the whole part. We copy this here. Okay, and then we copy the first addend. Okay. And of course, we will adjust the column widths. So we have 246. Our first mark is 128. First pick 118, so our next pick is 64. We have 54, so our next pick is 32. With 22, 16 follows. And we have 6, so we'll have 4 and 1. With 0.751, we can have zero point 0.5. We can also have 0.25. We have this? No. Can we have this? Also not. Can we have this? No. Let me just have to freeze this so that our answer will not, we can still see our sum. If we pick this, no. We pick this, also not, because we have two zeros. We'll head over to the one which has two zeros. Can we pick this? No. Can we pick this? Yes. Now we have a bigger precision because we are using 10 uh, binary places for our uh, fractions. So what we are doing here is just marking the blank spaces with zeros. Okay. And then we copy the same table, this time to convert to our we'll remove the marks because that is not correct, and we will copy our second addend, which is 146.6125. Yeah. Then we'll start picking. With 146, the first pick is 128. We're left with 18, so we can pick 6, 16, and 2. With 6125, we have point 0.5. We'll have 0.125. That's no, we can't have that. We can have this. Yes. We can have this. Yes. We can have this. Can we pick this? No. Let's try to pick this. No. So we'll pick this. Yes. And can we pick this? Yes. So we can now mark our blank spaces with zeros. So up to the most significant bit. Now what we'll do is put our addend side by side by copying the rows together. Put the first one here and the second one here. Remember that if you are going to add them, we'll have an expected result. Our expected result is 393.365. We should have an improved precision. We start at the last, so 1 plus 1 is 0, carry 1. 1 plus 0 plus 1 is another 0, carry 1. 1 plus 0 plus 0 is 1. This is a 0, this is a 1, it's a 1, this is a 1. Okay, let's expand further. 0 plus 0 is a 0, 1 plus 0 is a 0. 1 plus 1 is a 0, carry 1. 1 plus 0 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 plus 0 is another 0, carry 1. And 1 plus 0 plus 0 is 1. 1 plus 1 is 0, carry 1. And we have 1 plus 1 plus 1 plus 0 is 0. 0 with a carry of 1. 1 plus 0, 1 plus 1 plus 0 is another 0 with a carry of 1. Okay. And 1 plus 1 is 1 with a carry of 1. Okay. Let's try to check if we can plug this in to our table again. We'll copy this table. and check if the sum equals 393.69. Okay, let's delete this. Let's delete the mark. Then we'll just copy our answer, okay, up to the binary point. Undo that. No, I made a mistake. Okay. We'll have to copy this to the blank line. Have to copy this here. Okay, okay, that's correct. And then we copy the uh, value after the binary place. Paste this here. Okay. So we have 3.3.612.612.4037. Our previous value is it's our previous, no, that's anyway. This it's a different value, no. So our value is 3612.393612. So we still have a difference because, as you see, we did not have a complete conversion. We still have spillovers. But anyway, that demonstrates the point of how to convert into binary fixed point format using our binary table and how to perform addition. Thank you so much for watching this video. In the next video, I'm going to demonstrate how to add uh, floating point numbers using the same table. Thank you and see you then.